In the previous video, we looked at determining restrictions on our values of x in a radical equation. Now what we're going to do is we're going to actually use that and we're going to actually solve a radical equation. We're going to solve it graphically to start with using our calculator. So you're going to need your calculator out. I want you to try and work through with me what we're going to do on the calculator in a second. And we're also going to solve this algebraically as well. So the first thing we're going to do is we're going to state the restrictions for this. For what values of x is this defined? So we take x plus 1 is greater than or equal to 0. So we know x has to be greater than or equal to -1. So now what we're going to do is we're going to use our calculator to solve this, and we have a left side and a right side on our equation. So what we're going to do is in y1, we're going to graph the square root of x plus 1, and in y2, we're going to graph 4. And then we're going to determine the intersection of these two particular graphs. So I'm going to take out my calculator, and I'm going to go in, and I'm going to graph the square root of x plus 1 in y1, and I'm going to graph 4 in y2, and I'm going to hit zoom 6, and I'm going to see if we can actually see the point of intersection. In this case, what you're going to notice is we can't actually see the point of intersection of our graphs. We're going to have to go further to the right. So we're going to have to go into our window settings. We're going to have to expand our x maximum. I'm just going to double it. I'm going to say let's go to 20. So now we can see the point of intersection. How do we determine that point of intersection? Well, we go second function and trace, and we choose number 5 for intersect. And we keep hitting enter 3 times until it tells us the point of intersection is 15 and 4. So x is 15 when y is 4. So in this case, the solution is the x quantity of our point of intersection. Because we knew that y had a value of 4, we want to know what x needs to be to make this equation true. And if we verify this, meaning we check it back in the original equation was x plus 1, square root of x plus 1 equals 4. So if we put 15 in for x, 15 plus 1 is 16. And the square root of 16 is indeed 4. So when the left side equals the right side, we have verified it. We've confirmed that that's what the solution is. If we draw a picture in this grid of what we're actually looking at this and that. And we're actually finding the point of intersection is what we're finding in this question. Okay. So basically to solve something graphically, you just graph the left side and graph the right side and you find the point of intersection. That's all there is to it. Now, what we're going to do is we're going to look at solving algebraically. We're going to go through a number of different examples to help expose you to a number of different things you're going to see. We're going to start with the same equation that we just solved graphically. We know the answer is 15, but how do you get that algebraically? Well, the first thing we need to do is we need to remove the radical. And how do you remove the radical? Well, you square both sides of the equation. When you square a radical, you're left with the radicand. And don't forget to square the right-hand side, the 4. 4 squared is 16. Now, if we solve for x, we subtract 1 from each side, and we get x to be 15. And you always want to check your solution. You will see why in a minute, but what you will see is that not always will your solution work. So we get 15 plus 1 equals 4. Square root of 16 equals 4. So yes, 4 equals 4. Yes, that is a correct solution. Now we're going to look at a little bit more complicated question. We're going to look at 3 plus the square root of x minus 1 equals x. So basically what we do is we're first of all going to get the radical by itself. We're going to subtract 3 from each side, and you're going to have the square root of x minus 1 equals x minus 3. Now we're going to square both sides. If we square the left side, it removes the radical and we're left with x minus 1. When you square the right side, you need to remember that when you square a binomial, it means you multiply that binomial by itself. Lots of people miss this step. So if we expand this, we get x squared minus 3x plus 9. So the next thing we do when we solve an equation, we want to make the equation equal to 0. So we're going to move everything over to the right-hand side. So we've got x squared, negative 3x and negative 3x is negative 6x. Take one more x away, that gives us negative 7x. We're going to add 1 to 9, and that's going to give us 10. So we have a quadratic. How do we solve a quadratic equation? Well, we just did that in the last lesson yesterday. We have to factor this. We need two numbers that multiply to 10 and add to negative 7. Well, they are x minus 5 and x minus 2. So if we actually solve these, we get our two answers to be 5 and 2. But we need to verify these. We need to check them back in the original question. So I'm going to take 3 plus 5 minus 1 equals 5. Everywhere there's an x, I'm going to put in a 5. Well, 5 minus 1 is 4. So we get the square root of 4. Square root of 4 is 2, and 2 plus 3 is 5. So the first root checks out. Now let's check the second one. We're going to get 3 plus 2 minus 1 equals 2. Well, this gives us 3 plus the square root of 1 equals 2. Square root of 1 is 1, and 3 plus 1 is 4. 4 does not equal 2. So that means this is what's called an extraneous root. It is a root that we've calculated, but it does not satisfy our original equation, so it's not part of our original answer. How we indicate its extraneous roots is we just cross that particular root out. Okay, so basically, what you need to know about extraneous roots is that sometimes when you square the equation, it may lead to an answer which does not satisfy the original equation. So that's called an extraneous solution or an extraneous root. For this reason, it's always necessary to verify your equations algebraically. So you have to check your answers. If you don't check your answers, you're going to end up with solutions that don't work. Is the sadistic Mr. Kaminsky going to put questions on your quizzes and unit exams that require you to check? Absolutely. You're going to get questions where you will calculate two answers, one of them doesn't work, or maybe both of them don't work. So if you don't check your answers, you don't verify them, you're going to get tripped up. The steps we've been going through to solve our radical equations are these 4 steps here. First of all, you're going to isolate the radical, get it by itself. Then you're going to square both sides. And finally, you're going to verify your answers and see if there are any extraneous roots. So if we look at this first example here, we haven't had a question that has 2 radicals in it, but don't let it scare you. We actually have the radicals isolated on each side. So what we're going to do is we're actually going to square both sides of the equation here. So if you square the left side, it leaves you with x plus 3. And if you square the right side, it leaves you with 3x minus 5. So now we're going to solve for x. We're going to move the x's to one side. We're going to move the numbers to the other. So I'm going to start by subtracting x and get 3 equals 2x minus 5. Then I'm going to add 5 to each side and get 2x equals 8. And if you divide by 2, you get x equals 4. So now we need to check this. We need to verify that, hey, does this work? So I get the square root of 4 plus 3 equals the square root of 3 times 4 minus 5. Well, the square root of 4 plus 3 is the square root of 7. 3 plus 4 is 12, and 12 minus 5 is 7. So yeah, square root of 7 equals the square root of 7. This root works. Now we're going to do almost the same equation, except this time we have x minus 3 instead of x plus 3. So when we square both sides, we're going to get x minus 3 equals 3x minus 5. I'm going to subtract x from each side and get negative 3 equals 2x minus 5. I'm going to add 5 to each side and get 2 equals 2x. And when I actually divide by 2, I get an x value of 1. So now I check it. 1 minus 3 equals the square root of 3 times 1 minus 5. Well, 1 minus 3 is negative 2. 3 times 1 is 3, and 3 minus 5 is negative 2. However, if you look at this question, we can't take the square root of negative 2. It's not a valid or a defined solution. So what this actually means is that this particular question has no solution. It's not possible to get a value of x that satisfies the left and the right side. So there you are. Now it's time to practice solving some radical equations.